For this video today, I'll be building character development, which will include both the hero and enemy character with addition to their movement. So the first thing we're going to do in our C++ class is make a blueprint class from our base character. Once we've done that, we're going to rename it hero character and then head into the blueprint. So upon heading in, what you want to do is, under the mesh, we're going to need to add in the mannequin. Once the mannequin gets placed in, we'll need to align the mannequin so that it's mostly in the capsule component with its feet barely hanging out. Once you've done that, we'll need to add in a spring arm component. This spring arm component allows it to maintain a fixed distance from whatever it is attached from. Also, since the spring arm inherits the pitch, yaw, and roll like any object that is a parent of another, what I did in this case was turn off the pitch, yaw, and roll. And so, next thing we'll need to add is a camera. The camera component is made a child of the spring arm. And so I set both the spring arm and the camera's dimensions here. I rotated the spring arm -70 degrees, and I moved the camera back on the x-axis 100. Cool, just to make sure everything's working, what we'll do going along is bring in the hero character, and as you see here, this blue arrow indicates that once the player gets spawned in, or the character gets spawned in, it will be facing forward. So the next blueprint I created was a twin stick blueprint, which is a parent of the game mode base class. So upon entering that, all we'll need to change is the default pawn class, which will be our hero character that we've created. Afterwards, we're going to set up movement for the hero character. So, just a quick recap. All of the movements, move up, move down, left and right, as long as rotation with look up and look right, we've all done that back in the project settings in the input section for the axis. And so, obviously, first thing we're going to do is we need movement. So I brought in input axis move up, and then I dragged the node called add movement input. And so all I did was connect the axis value to the scale value, and then set the x to 1, because in this case the character will be moving forward, not up. That's why x is 1. I did the same thing for input axis move right. In this case I made the y 1, because y is when the character will be moving left and right. Next, I did rotation. So for the input axis lookup, I brought it in, and from the axis value, I dragged over and got the node make vector. And so lookup was connected to the x-axis, or the x, and the axis value from look right was connected to the y. There's nothing for z, obviously. And so from the return value, I got the vector length, and from the vector length, it's used to determine how far the stick is moved between 0 and 1. And so from that return value, I got in a float greater than greater than float. This is used to determine if the stick was moved beyond a certain point, or in this case a percentage. And so I set that percentage to 25. And so I dragged over from the float greater than. I got a branch, and originally this branch has a condition, and the condition is if it's greater than, of course, 25%, it'll rotate. Of course, we need to set these, and so I connected both look up and look right to the branch. And then afterwards, we need to make sure to set that if it's true, the character will rotate. And so I got the set control rotation node. And as well, I got the get controller node, and then connected it to set control rotation. And afterwards, back in the make vector, I got rotation from X vector, and then from there on, I connected rotation from X vector to the set control rotation. And so that is the setup for the base, all the movement and rotation needed for the character. As a quick demonstration: up, up, down, left and right, and in rotation as follows. Cool. Now we have our enemy character. So we're pretty much going to do similar things that we've done with the hero character to the enemy character. We're going to, in the mesh component, bring in the mannequin, align it to the capsule. Now we don't need a spring arm or camera in this case. What we want to do is show a distinct difference between the hero character and the enemy character. So what we're going to do is double click skeletal mesh. Once that's opened up, you see on the left hand side the materials that the model is comprised of. And they listed as element 0 as the main one, and element 1 as the next layer. So we're going to head into the material. All this is just needed to blend the materials together. But what we want to do is copy body color. Upon doing that, we're going to head over into the enemy character. And in the construction script, we're going to drag in the mesh, and we're going to bring in the create dynamic material instance. This node grabs whatever material found in element index 0, which I've shown, and converts it over to a dynamic version so that you can change any parameters found inside it. Once we've connected those, we're going to promote this return variable, promote the return value, and get a variable. We're going to rename this variable to Dynamat. Afterwards, we're going to drag over and bring in set vector parameter value, and so you'll paste, and so this is where the body color comes in. Then we're going to promote the value in the set vector parameter value, and we'll get another variable. We're going to rename this variable to enemy color. Now, in this case, since we've done all this, in the enemy character, in the viewport, we'll now be able to change whichever color we want our robot to be. Now that we've sort of set up the enemy character, what's needed is its movement. So we're going to head back in to the menu, and so we're now going to create an AI class. Now this AI class is found when we've searched up AI, and here you'll see here, controller. Once we've done that, we're going to head into the blueprint. So we're going to make a custom event called track player. This custom event is going to be connected to an AI move to. This node AI move to takes a pawn and tells it to move to a location or to a player, and once it gets within a certain radius, it will stop. So what we'll do is we'll get the controlled pawn, connect it over, get player character, and connect it over to the target actor. And so that's taken care of. But of course, we'll need it to continuously loop. So what we'll do is, with the event begin play, we're going to get the node set timer by function name. And so the time will be 1 second, and every second, once it touches the player, it will loop. Now that that's taken care of, the next thing we'll have to do is add in a nav mesh bound volume. The reason this needs to be added is because once you've first put your enemy character into the game, it will not move. It will not move even though it has its controls. So what we'll need to do is drag in the nav mesh. It's a cube, and with that cube, we'll need to scale it so that it encases the arena, or in this case, the floor. Once it encases the floor, now the enemy character will be able to follow the character, and that's the finished product you'll see here. Of course, I've slowed down the speed because originally it was too fast. So see, once it touches the player, in 1 second, it will continue to follow. Alright, so that concludes this video. Thanks for watching.